At 11:31 p.m. on August 3rd, a hidden launcher fired 5 drones into the night. 9 minutes later, one struck a $10 million power substation at the core of Russia's frontline base. In that brief window, a $5 billion logistics hub was cut off and thrown into darkness. Stay with me. What happened in those 9 minutes exposed a critical vulnerability in modern logistics, one precision hit that set off cascading paralysis. The key question is how such a strike began at all, right under the watch of an armed base. It began with a truck that looked like nothing more than an abandoned vehicle on the outskirts of town. 18 feet long, camouflaged and unlit, it drew no attention even though it sat barely 11 miles from the base. What no one saw was the set of composite tubes inside, 5 of them packed with Switchblade 600 drones. From the outside, it was just another machine left in the shadows. From the inside, it was a launch platform designed to operate without a sound. The brilliance wasn't only in the disguise. You don't need to be sitting at the front to fire the weapons. The operator watched a digital map 25 miles away and sent encrypted commands across a secure satellite link. That meant the truck could remain unmanned. No engine heat, no radio chatter, no signal that would alert defenders. Launching from far back didn't just protect personnel. It also blurred the trace of origin. There was no cockpit to shoot down, no pilot to capture. Inside the frame, hydraulics lifted the tubes into place. The movement was measured, almost casual, pitching them just above the horizon. There was no plume of exhaust, just the faint push of a compact motor. One drone slid free, then another, climbing with the stealth of a whisper toward the night. That silence was the weapon's first line of defense. By the time the drones gained altitude, radar operators across the base had nothing to mark on their screens. Think of the truck itself as a sheath for blades. The hidden tubes were the draw. One by one, the weapons came out, not through brute ignition, but through quiet release and precision timing. Each drone moved deliberately, as if already locked onto a cut that would matter. For decades, air raids required pilots to fly into heavy fire, risking both capture and death. This was different. Remote launch systems switched the risk profile. Crews could remain in safe zones, commanding at a distance. That isn't just tactical caution. It changes how responsibility is tracked. You only saw the drones in the sky. What you didn't see was who had sent them up or where they had left from. Now picture the Russian base. It was loaded with radar arrays, jamming towers, and interceptor batteries. On paper, that network formed a shield. But shields are built to deflect what you see coming. Nothing about that silent truck gave them any warning. In the time defenders assumed they controlled the perimeter, the drones had already cleared the riskiest few minutes of their flight, leaving the launch point invisibly behind. By the time operators checked their scopes for movement, the strike was already advancing. Silence had done its job. Concealment had done its job. What mattered next was whether those drones could actually cross the airspace in front of them. A gauntlet of layered systems built precisely to detect and destroy objects just like this. That opening act revealed how both sides were thinking. Ukraine leaned on mobility and stealth. Russia leaned on defenses and density. The collision of those choices was about to test whose bet mattered more. Because what stood between the drones and their target wasn't just distance. It was one of the most heavily defended zones in Europe. And the moment they entered that kill zone, every system Russia had invested in would come alive. Russia relied on more than walls and watchtowers. The Berdansk base was wrapped in a layered shield, Pantsir S, 1 short-range missile batteries, high-frequency search radars, and Kasuka 4 jamming towers flooding the airwaves. On paper, this grid was meant to stop anything moving through the air. In practice, 4 Switchblade drones still slipped through. The reason was simple. Each system had limits, and the drones were built to attack those limits in sequence. The Pantsir could only track a few targets at once. The radar needed altitude and clean skies. The jammers needed a signal to scramble. Stay with me. Here's how those weak points stacked up. The drones stayed just above the ground, scraping in at 150 feet. Instead of showing up clearly, they blended into clutter from buildings and tree lines. To you, that looks like a flat flight path. To a radar operator, it looks like noise and faint blips that disappear. At the same time, their links never stayed fixed. They hopped frequencies constantly and used a relay drone to keep the signal alive despite jamming. It was enough to keep operators connected, even as screens glitched with distorted data. Each fuselage carried coatings designed to diffuse radar reflections. Instead of sharp outlines, operators saw scattered fragments, then nothing. In old wars, bombers climbed high to rise above fire. These didn't. The switchblade skimmed low, trading altitude for invisibility, turning the horizon itself into a shield. Then came a critical setback. The relay drone, orbiting higher to extend the swarm's reach, was picked out and destroyed. For a moment, contact could have collapsed. Without that hub, the formation risked breaking apart over the kill zone. But the swarm switched instantly. Invisible laser beams linked drone to drone, stitching them together into one coordinated network the jammers could not touch. What looked like the end of control became proof of their resilience. Missile crews kept firing, but the swarm shaped their response. One drone pulled up and climbed into view. It was bait, deliberately obvious. Every interceptor fired at it was one less aimed at the others, hugging the terrain. Ammunition racks ran down, and operator focus shifted toward the decoy. The defense network wasn't destroyed outright. It was manipulated, forced to waste shots and time while the real attackers kept moving. Electronic warfare kept throwing static across the spectrum. Radar locks wavered, vanished, came back again. In the middle of it, the swarm endured. AI flight systems corrected for wind shifts and adjusted headings to stay exact within feet. And if a link dropped, control switched to autonomous guidance within fractions of a second. That meant the mission never hinged on one operator's feed alone. By the time the jammers quieted, 4 drones were still advancing. They had crossed through layers of defenses that existed to stop everything from helicopters to missiles. Russia's best systems hadn't failed, but they had been stretched, distracted, and forced to reveal their limits. Passing that kill zone wasn't victory, it was only access. Because ahead lay the real objective, and the reason those drones risked the gauntlet was not to hit random bunkers or tanks, but to break one single node that powered the entire base. Why focus on one electrical yard when entire rows of tanks and ammunition sat in plain view? Because that yard was the switch. The $5 billion logistics hub drew its lifeblood from a $10 million node, a 110 kilovolt substation delivering roughly 5 megawatts. Take out that node, and welding arms froze mid-hinge, surveillance screens flickered dark, and automated cranes shut down in silence. Ukraine's planners recognized that vulnerability, and that's why the drone's terminal dive went for the grid instead of the garages. Across several miles, the base functioned like a city built for war. Tanks stood under shelters, ordnance moved into underground vaults by robotic carriers, and repair bays buzzed with heavy machinery. Every light, every automated tool, every radar dish drew its current from one small lattice of steel towers and oil-filled transformers. For all the concrete bunkers and armored walls, the entire site still leaned on a single artery pulsing with electricity. That design flaw isn't unique to the military. Civilian life rests on the same fragile math. Metro areas depend on a limited number of substations. each feeding homes, hospitals, and transit. When one trips offline in a storm, neighborhoods vanish into blackout. Engineers warn about cascading failures constantly. A warfighting hub, no matter how fortified, lives under the same rule. Cut the power and the entire rhythm collapses. Inside the drone, sensors kept locking and relocking as jammers pushed static into the link. Its onboard memory compared the live feed against stored models until the steel lattice aligned. Below the tree line, it skimmed forward, its warhead armed and waiting. Each correction kept the course steady until the run turned kinetic. 9 minutes out from launch, it committed. At 11:40 p.m., with the other drones still dragging defenses into distraction, one unit pitched its nose down. Speed rose past 100 miles per hour. At 200 yards, steering ceased. Momentum carried it. The strike hit square into the transformer yard. The warhead's detonation tore through stacked machinery. Transformers ruptured, oil tanks flashed into fire, and arcs leapt across high-voltage lines. The blast didn't stop with the yard itself. Ignited fuel spread flame into adjoining storage. The cascading arcs set ammunition stores alight. One depot went next, driving a swell of explosions that rolled into the vehicle park. At least 10 T-72 tanks, valued in the tens of millions, burned out where they stood, all of it traced back to a single drone. The rest of the swarm had tied up interceptors or drawn fire. One found the mark. If you need a frame to picture it, imagine pulling a fuse from a switchboard. You flip one piece out, and suddenly the floor elevator stalls. Lights cut, and machines grind mid-cycle. Scale that up to thousands of tons of armored steel, and you understand why an entire installation froze at once. The lesson wasn't about RDX or fragments, it was about interdependence. A $10 million node supported a logistics system valued in the billions. Destroy the smaller, and the larger followed in minutes. The strike had knocked out more than hardware. It exposed the fragility of modern logistics built around single points of failure. But the real impact arrived after the flames. Darkness spread through command posts, storage bays, and repair lines. Vehicles sat stranded in their bays. Technicians stumbled through wreckage with no screens to guide them. That paralysis, the sudden stillness of a city-sized base, set off the wider chain of consequences waiting to unfold. Destroying that substation was not just a local disruption. It kicked off a ripple that reached all the way to the front. One strike on a $10 million node forced commanders to rethink how they could even hold ground in Zaporizhzhia. Analysts later estimated about a 20% drop in resupply capacity, and that single margin was enough to push Russian units into retreat. The breakdown came fast. Command posts went black, maps froze mid-update, and backup generators carried only a fraction of the load. Automated repair bays halted, their robotic cranes locked mid-lift, refueling systems stopped, conveyors jammed, and communications networks failed. Surveillance drones lost their ground support and fell from the sky. In the space of minutes, a fully mechanized logistics hub worked no better than a blackout factory line. That paralysis translated directly to the front. Fuel convoys didn't arrive on time. Ammunition shipments showed up short or late. Vehicles queued for repairs that never came, leaving armored strength parked instead of fighting. Units still in position bled firepower as their stocks dwindled until commanders faced a choice: hold with less or fall back to regroup. Some assessments even put the hub's downtime at 48 hours, but the shockwave of its failure extended far beyond that. Tell us where you're watching from. Why does this matter where you are? If you've studied logistics, you already know the math. Combat power is not only soldiers and armor, it is the constant rhythm of fuel trucks, repair parts, and resupply runs. Strip out that rhythm and you create gaps no morale can fill. Crews waited on diagnostics that never came. Artillery units rationed shells. Fire missions stalled even without direct enemy pressure. An army without resupply still looks intact until it can't shoot, move, or repair. Inside the wrecked hub, soldiers tried fallback systems, but most of them required the same grid now lying in flames. Radios sputtered to silence, radars spun but gave no usable signal, and encrypted lines fell out. It wasn't just inefficiency, it was disorientation. Commanders no longer had a live picture of their battle space. And with confirmation lagging, mistakes grew. Friendly movements were slowed, artillery fire hesitated, and coordination frayed. At the front, every missing truck carried weight. A single logjam delayed whole companies. Ukrainian fire pressed against weakened positions. Russian units could not sustain pressure when fuel tanks ran dry and ammunition racks thinned. That 20% cut in resupply doesn't sound catastrophic until you remember the front line consumes resources at a near constant rate. Fall below that threshold and withdrawals become mandatory. That's how one drone mission forced entire units to pull back kilometers from the Zaporizhzhia line. There's a historical echo here. In the Gulf War, Iraq's armored divisions didn't collapse simply from attack. They starved of supply after bridges and depots were hit. In World War II, German tanks froze because Allied raids gutted the oil network. And in Berdansk, precision drones carried the same lesson forward. Logistics are always a system, and when one node fails, the collapse stretches wider than the blast zone. The strike looks small, one transformer yard gone dark, but its consequences reach far. Orders were delayed, convoys turned back, and firepower diminished. The true battleground was never just trenches and armor. It was the fragile links that kept them alive. And that leads to the larger question this war continues to surface. What does it mean when the fate of a billion-dollar complex can be decided by a single vulnerable point? A $10 million node disabled a $5 billion hub. A lesson in systemic vulnerability. That is the essence of systemic warfare. One precise strike unravels a network that looks secure until it fails. This is asymmetric effect in practice, where small, precise tools deliver outcomes once possible only with massive force. The strike at Berdansk is clear evidence. It shows how every modern force depends on single points that cannot afford to be overlooked. If this analysis matters to you, like and subscribe. And here's the question to leave with. How many vital nodes are you sure are safe? Leave your take below.